because we finally got back to inertia, which is what I thought this conversation was going to be about, so I kind of jumped in here. Basically, I think I mentioned before the concept of inertia being something that's actually inherent in the gravitational field, and more to do with waves. I think Glenn's been working more and more towards a wave theory of gravity. I just saw his latest email on that. But basically, I think I've talked before about what inertia was with respect to waves in a gravitational field. It was quite a long time ago. If you might remember, Glenn, my thoughts on the subject of inertia was that if you had you dropped like a coin or a rock in the water, you got the water waves going outwards in a spherical pattern. And so basically it takes time for those waves to move out. But if you were to try to move the focal point of that pattern in any direction, it would take time for that entire pattern to start to move and reestablish itself. Like if you were to take a bobber and bob it up and down on the surface of water, and you were to just start to move that bobber in one direction or the other, there would be the already established waves that were in the space that would be reacting with the new waves that were trying to relocate the center. And so ahead of you, you would have a compressed wave, and behind you, you would have contracted waves. And it was going to take time for those waves ahead of you to move outwards, and they become weaker and weaker as they go outwards, and that's just geometry, right? You've got more energy, the same energy spread over larger and larger areas. So it takes time for that to happen. So the inherent inertia in space is inherent in the fact that space can only react to a distortion at a given speed, and that speed happens to be related to the speed of light for light. The waves I'm talking about here are more gravitational waves, and I can't tell you what the speed of gravity is. So many people have tried to make predictions, and I'm not going to try to make predictions. Since I believe that longitudinal waves are the source of gravity, and since we can't really see longitudinal waves very easily, we can look at just the spherical rings or circular rings on the surface of the water as the slice, if you will, of a longitudinal wave through the sphere. And you observed also, well, we won't go there with the waves. Anyway, because of these waves being ahead and already established, and because of this compaction, as you try to move the center, it is going to be a reaction to resist that motion of the center until such time as the new waves radiate out far enough that they haven't got much effect on that central point again anymore. And once you reach that point, now you have a bobbing pattern that's also moving linearly, and that bobbing pattern will persist. And you can look at this. You can try this on a moving stream of water. You can put a bobbing pattern in the water, and you'll notice that even though the water is moving downstream, if you continue bobbing that bobber and you remove the bobber, you will notice that that circular pattern remains where you started it, and it does not move downstream with the flow of the water. Okay, that's inertia. The wave pattern is holding itself in place because it's creating its own pilot waves. I think we've talked about. Everybody knows what pilot waves is by now. And the pilot wave experiments where they bobbed a drop of water or bobbed something up and down and created the pilot waves. I don't need pilot waves in what I'm thinking about, but we'll say there's a pilot wave. So the pilot is piloting a ship or something bobbing up and down. Okay, you guys want to call this matter at this point. Later on, we'll get rid of the matter. But that bobbing object is basically creating these waves in this space, and it's the fact that you have to move that whole pattern, and it takes time for that pattern to readjust to moving. And once that pattern has begun to move, then the waves that are closer, of course, are stronger because of geometry compared to the rest of the outer waves, and so they'll have a greater effect. But once you get far enough out, your inertia is going to become, your resistance to moving that center is going to become less and less because the whole pattern is now going to be moving. And if you try to stop the pattern, you have the same thing. You have all these pilot waves that are already existing that are moving forward in a direction and they're going to try to keep this central point moving also. That, in my opinion, is what creates inertia in the electromagnetic/gravity field, because they're the same field. The only difference between them is the gravity field, the gravity is being radiated out as spherical compressional waves, or I don't like to call them compressional waves, but for visualization purposes now we will, because we're talking about it in a fluid-like space. I look at it as a solid-like space, so they're really not compressional waves, they're rarefication or stretching or elastic waves pulling apart. But for visualization purposes, for the stick of the surface of the water, if you expand that surface to a sphere, you do the same thing in three-dimensional space. Now you have that inertial force, inertial resistance to moving that focal point in any particular direction because of the waves that are already established. That's my take on inertia. Okay, just to step backwards into, we're talking about entropy too, because I know we talked about entropy before in an email, and you described it as the mechanical loss. One of the ways I have always understood entropy to be defined is the degree of randomness in a pattern, in a pattern of motion and vibration determines the heat. And so when you're moving, when entropy is increasing, the randomness is also transferring to an area of non-random pattern to a random pattern. So hot area to a cooler area of the same material. And that's the way I see as entropy, is the motion of that randomness, the redistribution of that randomness. And in the sense of, if it's a closed space, as Dr. Lucas is saying, closed space, open space, I'm not going to make the distinction of the one or the other, because actually, if you have a limit to which things can move outwards, you could have a situation where it's just reflecting backwards towards the center. If it's a closed space, if I take a drum and I beat that drum once, and that energy has no place to go other than within that space, then if we have a non-particular media, which is, the electromagnetic/gravitational field, as you most recently described it again, is non-particular. You can take it down to whatever size you want, and you can't find a particle in it. It's continuous, and that's, I think, what you tried to describe in your description of saying, take it apart, you still can't get down to a piece. Okay, that's continuousness. If you don't have any parts to absorb the energy, then the energy just has to keep on going, and it's going to be then reflecting and coming back. So that single wave is going to become reactive with itself over and over and over again, and it's going to become more higher and higher frequencies. Because of the characteristics of elastic media, waves will move faster in a highly elastic media and slower in a like if you're moving in steel versus moving in taffy. If the steel softens, the waves will slow down. The greater the intensity of waves in a media, the more the media starts to get towards its ultimate tensile strength and starts to weaken and go towards where it's going to break. Well, you have a point where it starts to neck, and any material like steel will start to neck, and it'll weaken, it'll become pliable, and it won't transmit sound, for instance, as well as it does when it's a cold solid. That fact, those waves slow down in this. So when you generate these waves in a piece of steel, if you generate sound waves in a piece of steel, you'll heat that piece of steel up. As that piece of steel heats up, it becomes less able to transmit the sound waves because of its shear strength is being lost. Because it's less likely to transmit these sound waves, the sound waves that you're traveling by it in a plane wave will naturally start to slow down as it approaches the center of this hot spot, but they will still go fast around it, and therefore the waves will actually curve around this center hotspot, and they'll start focusing on each other. So any waves that are encountering this are going to start to wrap around that spot And because they're wrapping around that spot, the waves are getting denser in that spot. Because they're getting denser in that spot, the media is becoming weaker, and because the media is becoming weaker, more waves are pulled in. So gravity waves moving by in this electromagnetic field are weakening. The gravity is existing. The gravity waves in the first place is weakening this field. And as this field becomes weak, it naturally tends to have a focusing effect of these waves. These plane waves will start to wrap around it. And this is how the waves become focused within this media, electromagnetic gravitational field. And that's how you get a particle pattern. Okay, now I went too far because now I'm starting to describe a particle, which I wanted to throw out because I said I don't believe in particles being separate. I went too far. I described basically inertia as the characteristic of the wave pattern, the pilot wave, and the sustaining of the pilot wave holding the focal point in a location. Does that jive with anybody? Does that make any sense as far as what potentially inertia is in a unified field or in a gravitational field?
Well, it's certainly interesting and requires some thought and maybe listening to that again and again. Dr. Lucas, have you got a reaction to that? This is kind of new ideas.
Yeah, I went to the University of Maryland, College Park, and when I went there was the world's largest physics department, and it was built by John Toll. And one of the groups in that department, we had 300 full-time faculty in the physics department and 600 new graduate students every year. And so that's why it was larger than any other university in the world. But one of those groups that did research was Weber's group, and they were trying to measure the gravity waves. And they did the most, I guess you would say, sensitive, highest resolution experiments done to date on trying to measure gravity waves. And they were not able to measure any.
So let's say the gravity wave they're talking about is if I go shake the moon, I can feel the wave from the moon. We're talking about the modulation. The gravity wave I'm talking about is not the long, mile-long gravity wave. The gravity wave I'm talking about is the wave that becomes the focal point, becomes so finely focused that it becomes a neutron. Okay, its pattern of focus is a neutron size. So we're talking about minute subatomic wavelengths of gravity. Glenn, you pointed out before, and I've pointed out several times that you and Franklin observed, and I've observed a phenomenon where when you look at the waves as they radiate outwards, they lengthen. Okay, so the gravity waves that Weber and these guys were trying to study was the integration of all the individual mass waves from every single neutron, every single piece of mass in an object as a group. So it's a group pattern of moving like a ball or a moon or something like that, and seeing if you can see that group's result of that group, not the individual actual gravity waves are focused down to like a single neutron would be the focal point of a gravity wave. You take a gazillion neutrons like the Earth or the Moon has, and you try to detect gravity, all you're really detecting is the integration of the conglomerate of all those waves. And that, in fact, each individual neutron, generates a gravitational pattern, or is a result of a gravitational pattern. But the summation of all of them all pulling on each other that we sense as us being pulled towards the Earth. It's not just one pull of gravity. It's the summation or the integration of every particle of our body being pulled to every particle of the Earth. So I think what you're talking about with Weber and those guys, if I'm right, I'm trying to think again. I lost track. Who was Bill Lucas, Mr. Lucas. What you're talking about is that those guys are trying to study these longer range modulations, if you will, of the gravity. Does that sound right? Not necessarily the individual gravity waves that we're talking about, that are the true gravity/gas waves.
I'm not sure I'm understanding perfectly what you're saying, but they were doing experiments in the lab where you would have two massive bodies, and they would try to measure the gravity waves between them.
Correct, yeah, and that was, like I said, that's the integration of all those massive bodies within that body, because they weren't dealing with a neutron, they weren't dealing with the gravity waves, they were dealing with the summation of all of them.
Yeah. Well,
I would agree with your analysis there, Corey.
But neutrons, we've never been able to measure gravity waves between neutrons, like in accelerator experiments where you make a beam of neutrons. We're not able to measure that, as far as I know.
Expect to be able to, because neutrons are made of gravity waves, so you wouldn't be able to expect. How would you measure a sound wave with a sound wave? Type of thing.
Well, one curious thing is that neutrons are gravitationally attracted. I mean, they've done these very precise experiments where they've shot a beam of neutrons, actually watched them drop and bounce off of something. But now, curiously enough, it's really hard to measure the effect of gravity on, say, things like electrons. It's so difficult that I'm not sure that they've been able to do it, or that the results are that electrons are not gravitationally attracted.
Well, it's hard to measure anything that's individually that small and measure gravity on it, because that's why Weber and those guys were doing experiments in the lab with a conglomeration, a steel ball or something like that, because that's the only thing that generates enough gravity for us to be able to measure it. The other thing about gravity is that it is a very weak force, because it's not the force in each individual wave, it's the force that's generated because of the delta in energy between successive waves of this spherical wave pattern. It's not the energy in each individual wave. Where you feel the energy in each individual wave more is when you start getting down to neutron being very, very close to neutron and how they react, or the electron being very close to photon and how they act. It is the difference between the weak force and the strong force. The gravity is not, like I said, gravity is not the amount of energy in each individual wave. It's the delta between them. Let me give you another example, if you want to wait a second here. I put out a question earlier about how do you get, and this is related to fluid flow, how do you get attraction into a point with a fluid flow? And a lot of people are thinking gravity is like a fluid flowing towards a point, and so things are getting sucked in by that fluid. And so my question was, can you have that attractive force without actually having the fluid flowing towards the point? And this is where I basically began with one of my theories, and that is that if the fluid flows in towards a point, you have the fluid flow naturally has to be faster towards the center, because you have a greater density, a smaller area. So your fluid is flowing faster and faster as you go in from the sphere towards the point. Does that sound correct? In order for otherwise your fluid's going to stack up and you're just going to go nowhere. Okay?
Well, that is a fundamental problem with any theory like that.
We're going to overcome this problem, okay? And I asked this question and nobody's answered it yet. I'll answer it myself. If you do the same thing and the fluid moves outwards from the center, again, the fluid towards the center is moving faster than the fluid towards the outside. Okay, so now let's put an object in this fluid field that's now going outwards and then going inwards. It's going just constantly outwards and inwards past this object. So you've got this object, and there's a wave of fluid flowing out past it and back in towards it. That object will be attracted towards the center. Does anybody have an understanding of why yet?
No, because the outward pressing fluid would cancel the inward fluid.
99.999%. Exactly. 99.99% of the time, that's correct. Okay? But there's this little thing about what I just said. Fluid is flowing faster towards the center than it is towards the outside. Now, from a standpoint of fluid dynamics, what does Bernoulli's principle tell you about fluid flowing faster on the inside of this object versus on the outside of this object? If you sum all those vectors,
but it can't do that unless some of it is building up inside.
No, it doesn't. Bernoulli's principle doesn't say that the fluid direction has to be towards center or away from center. It says it has to be faster on one side than the other. It doesn't say whether it goes. It doesn't say which way the fluid has to flow. It says the speed of the fluid. It's not a vector. It's a quantity. So if the speed is flowing outwards, or if the fluid is flowing outwards or inwards, it doesn't matter. The speed towards the center is going to be faster simply because geometry says it has to be. And if the speed on the inside is faster, then yes, you're right. There's a push and a pull on the outside of this surface. But there is also a vector summation. If you sum out all the vectors of the forces on that surface, there's going to be a vector summation generally that regardless of whether the fluid is flowing outwards or inwards, over the average of the entire cycle, inward-outward cycle, there is going to be a pull inward because Bernoulli's principle says there is going to be.
I don't think so. I think the outward flow would have to always equal the input flow. If your object is not a storage.
Map yourself and see if that makes sense, because I think you need to have time for that to soak in.
No, I think that all conceptions of attraction as being a sink and a source are going to have that fatal flaw that, you have to either explain where all of this stuff flowing is going out, and I don't think you can explain that. But you've got an interesting twist on that. You're saying that it's going back out, but at a different speed. But I don't see how that can happen either.
Okay, well, give it some time, look at it offline, and come back to me about that if you want. But that's my take on fluid dynamics of this. And that's where I said I started with the theory of fluid being a model of space, and moved on to no longer fluid is a solid, and there are no particles, and everything is waves. I think it's about as close it's fairly close to what Dr. Lucas's concept is, I believe. Although the pattern of waves and the characteristics of the various waves and their relationship to the properties of matter may be slightly different. But I think Dr. Lucas also, I believe, has pretty much a wave concept of matter and energy. That sound correct, Dr. Lucas? Am I misinterpreting something on yours?
I would say that's close. Who is this that I'm speaking with?
Corey Verhey.
Corey? What's your last name?
Verhey. Oh, yes. Yeah, you should be copied on quite a few of my emails, I think.
Yeah, I think I have. I just haven't heard you speak before. So I appreciate your participation today.
Actually, I'm going to have to cut out pretty quick here because I'm extending my 15-minute break at work by quite a bit.
Yeah, I'm sitting in front of my computer at work, so but really should get done by 9 o'clock.
Okay, so those are my inputs and thoughts. I do have to be going. I'm sorry to leave the short as I'd like to participate more, but I'm kind of stuck where I'm stuck.
Well, okay, Corey. I'm glad you could join. I know Corey listens every week. You've certainly given us some things to think about. First time around, there's some very interesting things that do resonate in my mind.
Yeah, you've been listening quite profound, quite well, Glenn. I think I'm seeing more and more of your writings leaning towards the wave concept. And I've kept on commenting in a couple of emails here lately that sooner or later you'll fall into the conclusion that matter and energy can convert, but I'm not pushing the issue.
Yeah, I
think you're right.
I'm going to have
in that direction yourself.
I'm going to probably have a big problem with that. Okay, Corey, before you leave, you want to give a summary, just a brief summary?
Well, I think I pretty much summarized everything, and then the only thing I was listening to was the talk about heat distribution and entropy, and I think I spoke there of the enclosed space, and that entropy would constantly increase because the waves would start to interact with each other, and heat would build. It has no place to go, and they're in a media that doesn't have particles to absorb the energy. You can't lose. You're not going to lose the energy. As a matter of fact, what's happening is the media is becoming more and more interactive with itself, and because of what I said about the potential, the characteristics of the media itself changing, which relates to actually the permeability and permittivity of free space, it is not the same everywhere. It is affected by gravity and the density of matter in the area, and the waves are basically self-generating, not self-generating, but it's self-sustaining because it's in there. It's got no place to go. The only thing it can do is form more and more complex patterns of interactions with itself, and those complex interactions with itself are what we see as particles. And yes, those complex interactions itself do eventually absorb more energy and come into heat, but they're coming into being in the first place with the fact that they were waves interacting with themselves. They're just becoming more and more complex waves all the time. So that's basically my summation of how the Big Bang, if you will. And I don't subscribe necessarily to the Big Bang, but basically I do believe that there was an evolution of the void, as you described it now, Glenn. I don't know if you read my email or my writings on the CNPS website as far as the description of the void, but we're pretty much in agreement on the description of the void. There's something there, but you can't see it if it's not active. So it's coming from the void and basically creating matter out of that void, and how that can happen, and how it happens on its own by just putting the energy in. I'm not going to speculate where the energy originally came from, because as I said before, that's beyond the scope of physics. Whether there's additional energy being put in or not is probably also beyond the scope of physics. But once that energy is in an enclosed space, like Al was saying, if it's in an enclosed space, and you may have to be able to put it in a vacuum container or something like that, but when you talk about, true space, there is no place else for it to go other than within itself. So the only thing that can happen is entropy can increase, the randomness of interactions can increase in an environment like that. And that's pretty much my summary.
Okay, very good. And again, welcome aboard. Franklin, I know you've got to leave. You want to try to summarize at this point?
See you guys.
See you, Corey.
Okay. I think we've had some interesting discussions. We really didn't get too far into inertia.
No, we didn't.
We really kind of got cut off